Hi guys, welcome to this week's screencasts on the vascular system. Before we start talking about the vascular system, just a quick recap of what we did last week. So we looked at heart rate regulation, specifically intrinsic control and temperature changes and venous return changes. The reason why I'm going over what we did last week is because we're going to be looking at something to do with venous return in today's lesson as well. So as I said, heart rate regulation, we looked at intrinsic control, which is temperature and venous return changes, as well as hormonal control, which is to do with adrenaline and noradrenaline. Now, with regards to intrinsic control, when we speak about venous return, we also mention the fact that stroke volume responses to exercise, and that was to do with an increased venous return and the Frank-Starling mechanism, or Starling's law, as we learnt it, and other information with regards to stroke volume, so the fact that it reaches its maximum at 60% of exercise intensity. Then we also looked at cardiac output responses as well. So moving on to the vascular system. First of all, the vascular system, what we need to know it as is a dense network of blood vessels and the blood which carry kind of nutrients and oxygen around the body and glucose, etc. So vascular system, we're talking about the blood vessels. So you've got arteries and arterioles. These carry oxygenated blood away from the body. Then we have capillaries. Capillaries bring the blood slowly into close contact with the muscle, and that's where gaseous exchange takes place. So, for example, oxygen goes into the muscle, carbon dioxide leaves the muscle and goes into the capillaries, into the blood vessels. Then from there, from capillaries, we have veins and venules, which carry deoxygenated blood back to the heart. We'll go on about them in more detail in lesson, but for now, that's just the kind of like little network you need to know with regards to blood vessels. And this is where we get on to today's screencast topic, which is venous return mechanisms. So first of all, your Cornell notes should look like this if you pause this and get these down. Right, okay, so venous return mechanisms, pocket valves, one-way valves located in the veins which prevent the backflow of blood. Now you have to think we need to get blood back to the heart from areas that are below our heart, so our feet, our legs, etc. Because of gravity, blood will go straight back down towards our feet if it wasn't for these pocket valves that prevent the backflow of blood. They prevent the blood going back towards our feet, our lower body. Then we have smooth muscle. A layer of smooth muscle in the vein wall vasoconstricts to create venomotor tone, which aids the movement of blood. So vasoconstriction is the narrowing of blood vessels, which we'll go on about in lesson. So when our blood vessels narrow, that is what vasoconstriction is known as. Think of a boa constrictor snake, narrowing, squeezing. Gravity is a mechanism that helps with venous return. So blood from the upper body above the heart is helped to return to the heart via gravity. Then we have something called a muscle pump. So during exercise, the skeletal muscles contract, compressing the veins, squeezing the blood back to the heart. Respiratory pump is the last one. So during inspiration and expiration, a pressure difference between the thoracic and abdominal cavity is created, squeezing the blood back to the heart. So these 5 things here help aid with venous return. So we learnt about venous return last week, which is the blood from the body back to the heart. This is what helps increase venous return during exercise. I really want us to concentrate on these key questions, guys, in the corner notes. Some of you don't do them. It's just lazy. Get them done appropriately, correctly, i.e. put in some of these key terms within the question, which will help you get the right answer. So if you can do that, I will see you in tomorrow's lesson. Thank you. Bye.